Here's a projectile. Okay? Why is that significant in kinematics? Look at that. I throw it up and it comes back down. Let's see if it does it again. Hey! Why? Why does it happen? Maybe you asked that when you're in your high chair. I don't know. Projectile. Anything that's thrown in the air. It usually does, unless you throw it really, really, really far. Then it might leave the atmosphere. It's pretty hard to do, though, with this much gravity on this planet. All right. Projectile. So, example. We got VO. Let's write some words. An object falls from 100 meters. What is its final velocity? And this isn't really anything new. We've done this before, but we're going to manipulate this question a couple of different ways. So, again, picture's worth 1,000 words. Some of these, especially in Physics 12, it'll be really tough to do some of these questions without a picture. It's nice to get in the habit now, if you're planning on taking that course. So, here's my picture. I have an object. It falls, I drop it, same difference. It's called free fall, falls. We ignore one thing though. In practice, there's air resistance. It's a form of friction. We ignore that because it's pretty tough to do the question if we don't. Okay, start with what you know. What do I know? I know it's going down 100 meters before it hits something at the bottom. What else do I know? When I drop it, what's its initial velocity? Nothing. Zero. And assuming this is on Earth, and you assume that unless we tell you otherwise, what's the rate of acceleration as it goes down? Yeah, g, which is an acceleration, it's 9.8. Everyone's got that memorized now? I hope so. And you know what? Hey, if you forget on the test stress and all, I can tell you. Okay, I want to know its final velocity. VF is what? Look up your formulas. There's probably a formula that has D, VO, G, and VF. And hopefully you come up with that one. Okay, so don't forget to square or square root here. Don't forget these squareds. Don't forget the squared on the other formula. That's got a t squared. Okay, this should work. I'm trying to find VF. So VF squared is VO 0. So that's gone. That's nice. 2. Acceleration 9.8. And the distance it goes is 100. Is that distance it's going in the same direction as the acceleration? Let's keep that in mind for a sec. It is. Both down, right? Just falling down. All right, so VF squared is, what's that stuff? Two times 9.8 is 19.6 times 100 is 1960, but don't forget, got to take the square root of that. Okay, so my final velocity is square root of that is 44.3. Let's round it to the tenths. Okay, and I think it was the last quiz. I mean, someone wrote like 9 decimals here. Okay, that's just silliness. Don't worry about it. Don't do it. We're kind of past sig figs. Technically, I should put this at 44, but just put it at the tenths, okay? So that's the final velocity. What direction? downwards. And someone also asked me, well, isn't the final velocity 0 because it hits the ground? Yes, but when we say final velocity, I mean just before it hits the ground. Because we know it's going to be 0 when it stops moving. Okay, we're not interested in that. That's a boring question. Okay? So that's not new. We've done that before. Now, we now throw the projectiles, the word, down at 5 meters a second. What is its final velocity now? Good guess, though. But what do we expect? Common sense here. Is it going to be greater than this number? We would hope so, right? Okay. So I'm throwing this down. VO now is 5. You got to think about direction here. Is the acceleration in the same direction as the initial velocity? Yes, that's why a picture helps. They're both going down. It's not hard to visualize this, but these are in the same direction, so they need to have the same sign. And we're going to assume down is positive, and they do. Okay? So, A and VO must be in the same direction. Because if for some strange reason on this planet, if we threw it down and acceleration went up, would it hit the ground? Maybe. Depends how hard I threw it. But at some point, I mean, it's slowing down as it goes. We know that doesn't happen in practice, right? Ooh, now let's not overthink things, okay? Yeah, helium's lighter than our atmosphere, so it's going to rise. What else do I know? Same cliff or whatever I'm throwing it off. Okay, I want to solve for VF. Same formula or a different one? Sure, why not, right? Same formula. VF squared is VO squared plus 2AD. Okay, write it out on your questions on your test, because right there you probably got 1 out of 2. Okay? Now lots of you made mistakes on the quiz, you noticed, and got the wrong answer, but still, well, I haven't handed it back yet, so you don't know. But a lot of you got 1.5 out of 2 with even getting the wrong answer, because that basic algebra here that we're doing, some of you still need some practice with it. Okay? Practice, practice, practice. So VO, it's not 0 now, it's 5. Don't forget to square it. People like to forget that. Acceleration down, I take as positive. Displacement going down, I'll take that as positive. It's in the same direction. If you have a good calculator, that's just one line. Okay, a little bit bigger, 1985. But remember, I got to take the square root of that. It was a good year, 1985. Is that bigger like we expect? Yeah. Okay, not much though, is it? Very little. So someone guessed, don't I just add 5 onto this one? Doesn't quite work like that. Use the formula. Figure it out. So now you know. 45, let's round that, 0.6. So it is faster. Maybe you're hoping for more, but at least it makes sense. Okay, if I throw it down, it better hit the ground at a faster velocity than if I just drop it. Okay? So, one more. Guess which way this one's going to go? Yeah, because you know what? We've seen a problem like this too, haven't we? Now, Lewis, pay attention. We're going to throw it up at 5 meters a second. What's going to happen when we throw this thing up? Has anybody ever seen this before? It comes back down. Okay, so we're throwing this thing straight up. We're not doing 2 dimensions here. That's physics 12. We're in one plane. So it's going to go straight up and straight down. But for me to see it, I'm going to make it look like I'm throwing it out sideways a little bit. Okay, understand? Because if I got one line going straight up and down, it's going to look like that. And it's harder to visualize than this guy. Okay? Right? So I'm throwing it up. So VO is 5 meters a second. But what do we need to do here? Because you know that's a different problem than this one. We have to make some kind of change. Yeah, what am I going to take as negative here? If I want to take, let's be consistent and say, well, I had a positive there. So let's still make it positive, but this has to be the opposite direction. Okay, so A and B now must be opposite directions, because the formula doesn't know what picture you drew. You have to put in the appropriate numbers. One of these has to be a negative, or it's going to give you the same answer. Okay, it's only as good as the numbers you put in. Must be opposite direction. Okay, so let's take our velocity as negative. Okay, so down's going to be positive. Let's go up. Must be the opposite direction. It's got to be negative. And same distance, 100 meters. And of course, I'm solving for what's my final velocity just before it hits the ground. And same formula, plug in my numbers. VO now is negative 5 squared. And what do we notice here? Yeah, because what happens when I go negative squared? It becomes positive. But we know that can't happen. Okay, I'm still going to get 25 here, aren't I? So I can't do that. I got to think common sense. This thing couldn't possibly reach the ground, okay, at the same speed as that. So I'm going to have to revise this a bit. Let's take this as positive, and then A must be negative. Okay? This will give me the same answer. So I'll take up as positive, down as negative, and like I told you guys, that's a usual convention that we do in textbooks and teachers. We normally take down as negative. So if I throw something up, it just feels better if that's positive direction. Okay, so D is still 100, trying to find VF. So now VF squared is, if I take that as positive, plus 2A D. Okay, what happens if I do that? 25, and is this number going to be positive or negative? Yeah, positive times a negative is a negative, times a positive is a negative. So let's just make that a negative. So this is, I already did this about 3 times, but let's do it again. Minus 1960. And VF squared is, what's that? Take away that. These signs are opposite on my calculator, but isn't this negative 1935? And does anyone see a problem here? Uh-oh. Can't square root a negative. What did I forget to do? If I'm taking down as negative, then this thing, as it travels in this direction, is going down. My displacement needs to be negative too, to be consistent. Okay? Up is positive, down's negative. This thing's traveling a distance down. I need to take that negative, because down is negative. And if I do that, then I will be fine. And this will be a positive. Let's change that. And 1960 and 25 is 1985. And what's the square root of that? Whoop. Hey, that rings a bell. 40. Hey, what? Huh? Why am I doing this? Because this is what it is, brother. I got the same speed. Does that make sense? If I throw it down at 5, or I throw it up at 5, it ends up hitting the ground with the same speed. Huh, does it make sense? Let's look at this for a sec. If I throw this up at 5 meters a second, any guesses as to what speed it's coming down with just before it hits my hand? You think so? You think that's like, what's the acceleration on this right now? What is it? No, the acceleration. It's 9.8 down. Because if I let it go, that's where it's going to accelerate down. I'm holding it up, but it's still under acceleration. Okay? What is its acceleration at the top? Gravity's not affecting it at the top. It's still 9.8. What's the gravity when it comes back down? Anywhere in this path, it's going down at 9.8 meters a second. Velocity, if I throw it up at 5, what's its velocity coming back down? It's 5, isn't it? It's the exact same problem. Let's analyze this a sec. This part right here, let me get a new page. Whoop, I don't want that. When I throw this thing up, again, I'm throwing it straight up and it's coming straight down. I'm just making it look like it's going sideways just so we can visualize it, okay? It goes up at 5 meters a second. Acceleration is always down at 9.8. That doesn't change. Okay, gravity doesn't change irregardless of where this thing is, right? But the whole time it's getting slower and slower and slower until, what's its speed right here? Is it 0? At the top? It is. Doesn't it stop and change direction? Is that any different than a car driving down the road and then going backwards? Does it not have to stop before it changes direction? Yeah. Okay? Its speed at the top is 0, and then it starts going the opposite direction, increasing, negative, until right here it's doing 5 meters a second again, only in the opposite direction. What kind of a shape do we call this thing? Those of you who have taken Math 11? That's a parabola. And what do we know about parabolas? They're symmetrical. This left side looks exactly like the right side. Okay, there's symmetry going on here. Whatever happens on the left is exactly what happens on the right. It's just the opposite direction. Okay, remember this stuff. That's a tricky question. Oh, I won't cross that up. So, isn't that the same problem then? If right here it's going down at 5 meters a second, that's exactly what we had in our second example. Okay? Doesn't change it. I'm going to solve this problem again. I'm going to do it differently. I want to know what the speed is at the bottom. Have we done problems where we're dropping it from a certain height? Sure we have. That was the first example I did. Only I want to know what the total distance is. I know this is 100. What if I find out this distance here, d, add it to this distance, and then pretend I'm just dropping it? Okay? So I want to do this in two parts. I want to find out this distance. If I throw it up at 5 meters a second, acceleration is the opposite direction. It's always 9.8 down. What's my speed at the top here? It's 0. It stops. I want to know how high it gets. Does that sound like maybe something we're going to do with our bottle rocket? Yeah. Good guess. Because that's exactly how we're going to find out how high it goes. We're going to use the time, not the initial speed, because I don't have a radar gun, but it's essentially the same problem. At the top, it's 0. It changes direction. Okay, its speed is 0. It has to, because it goes up, stops, and then starts coming back down. So I just want to find out how high does it go? What's the distance here? Okay, so once again, we should be getting this formula memorized awfully quick. I know VF is 0. VO is 5 up. Acceleration is 9 down. I want to solve this thing for D. So, some of you guys are still having problems with this. How do I solve this thing? What do I want to do first, Merrill? Oh, thanks. Thank you. Yes, first I want to make sure I don't forget the square like I keep telling you guys not to, and then I did it. All right? What do I want to do first here? Let's rewrite that. 0 is 25. What is 2 times negative 9.8? 19.6 negative times D. Do I want to divide by 25 here? Austin, what do you think? I think you should be paying attention. That's what I think. What do I want to do with 25 to get rid of it? Subtract it. Okay, minus 25 is negative 19.6 D. How do I get rid of the minus 19.6? Divide it away, because it says 19.6 times D. So you divide. And negative divided by a negative, is that a positive? Is that up? The opposite direction as what I took as negative down? Yes, it is. So it kind of makes sense, doesn't it? So D is, what's that? 25 divided by 19.6 is, that's only 1.3 meters. Okay, that's how high it went when I threw it up. Now, forget all that. I got a new problem. This thing's falling from the top. What's the total distance it's going? This is 1.3. This is 100. So I want 100 plus 1.3. That's how far it's falling now from free fall. It's the same problem, isn't it? Only now it's up here. A is 9.8. If I take this as positive down, then I want that to be positive too. You can make them both negative. It'll be the same thing. And what should I get for an answer? I've already done the question, haven't I? Right? I'm just trying to confirm it using a different method. 0 and 2, 101.3 and 9.8, and I should get what? 1985. If I take the square root of that, have I done this already? Yes, I have. A couple times, right? Now let's do it again. Oh, 44.6. Bingo. Okay? So, there's lots of different ways you can do these things. Formulas will always work unless you make a mistake. It just gets a little more confusing because now we got to think about direction. Okay?